Hello everyone, so today in this video we are going to discuss the question counting rectangles which is asked in Codeforces Round 1817 Div.4. In this question we are actually given n rectangles and we are given few queries. Each rectangle is of the form HIWI, that is the height of the rectangle and the width of the rectangle, and we are given queries of the form HSWS, HBWB, where what we actually have to tell in this question is how many rectangles satisfy how many queries, and we have to report that answer. So let's understand this question with the help of the test case which is given to us. Let's understand this first test case, and with this test case let's try to understand what the question is actually trying to say to us. So in this test case we are given 2 1 2 3 3 2 1 1 3 4. Here 2 represents the number of rectangles which we are given to us. Let me change the color. The number of rectangles which we are given to us, and here 1 represents the number of queries which we are given to us. One query is given to us. We have to tell that how many rectangles will satisfy how many queries. Let's say suppose 2 rectangles, let's say suppose both of the rectangles satisfy this query. Let's say only one of them will satisfy this query. We have to tell this only. So what is the meaning of rectangles satisfying the query? So we are given a rectangle of 2 cross 3. We are given a rectangle of 3 cross 2. And the queries of the form 1, 1, 3 and 4. Okay. So let's consider first this one, rectangle of 2 cross 3. Let's make a rectangle of 2 cross 3. Let's say this is a rectangle of 2 cross 3. We don't have to rotate anything in this question. It is clearly mentioned in this question that we won't be able to rotate the rectangle. So this is a rectangle of size 2 cross 3. Now first understand what the query says. Query first 2 digits says 1, 1, and other 2 says 3, 4. 1, 1 means a rectangle of 1 cross 1. So we can say is a rectangle of 1 cross 1 can easily be able to fit inside this 2 cross 3 rectangle, such that it will not touch its line. If it will touch the boundary, it means we can say that it is not enclosed. We can see that the 1 cross 1 rectangle is actually enclosed within 2 cross 3 rectangle. 1 cross 1 rectangle is actually enclosed within 2 cross 3 rectangle. So I can say, okay, 1 cross 1 rectangle is enclosed. I can also use these other two numbers 3, 4. That the 3 cross 4 rectangle. That the 3 cross 4 rectangle encloses, is not enclosed. I am saying encloses. I can say that this 3 cross 4 rectangle encloses the 2 cross 3 rectangle. Okay, this is fine. 1 cross 1 rectangle is enclosed within 2 cross 3, and 2 cross 3 rectangle is enclosed within 3 cross 4. So I can say, okay, this rectangle fits the query. This rectangle fits the query. Now let's move to this question. We are given a rectangle of 3 cross 2. Let's say I draw a rectangle of 3 cross 2. In this, I can easily be able to fit a rectangle of 1 cross 1, such that neither it touches its boundary nor it will move out of the boundary. Suppose instead of 1 cross 1 it is 4 cross 1. So as you can see, the height is 3, and if the inside rectangle is of height 4, so we won't be able to it will become like this, 4 cross 1. So we won't be able to fit inside that. And we can see that this 3 cross 4 rectangle, when we are trying to make the 3 cross 4 rectangle, we can see that this is actually 3 cross 4 rectangle. 3 cross 4 rectangle. We can see that this 3 cross 4 rectangle, let me make it with green color, this 3 cross 4 rectangle touches with 3 cross 2 rectangle, or I can say that the 3 cross 2 rectangle is not, if it is touching, we can say that it is not enclosing. We can say that the 3 cross 2 rectangle is not enclosed within 3 cross 4. So I can say here it is not fit. Here it is not fit. So in this form, we have to tell how many rectangles fit how many queries, and we have to report the answer. As there are n queries and there are n rectangles and q queries, for every rectangle we will traverse every query, and this will lead to the time complexity of order of n into q. And we can see that as n is of the form 10 to the power 5 and q is of the form 10 to the power 5, so it will be equal to the order of 10 to the power 10, which will definitely lead to TLE. So So which concept we will apply? So we will apply the concept of 2D prefix sum. 2D prefix sum. So we will apply the concept of 2D prefix sum. So let's see how, if you don't know how to apply the concept of 2D prefix sum, I must say you must first learn the concept of 2D prefix sum. It's actually very easy. It's actually concept of DP. Don't if you see, if you, I am writing the transition here. If you find the transition difficult, don't think it's difficult. Once you understand what is actually 2D prefix sum, you will be able to write the actually transition on your own, and believe me, it is not difficult. Actually, the transition of the form is dp of ij is equal to dp of I minus 1j plus dp of I j minus 1 minus dp of I minus 1 j minus 1 plus v of ij. Actually, the transition is of this form. If you know believe me, if you know 2D prefix sum, this transition is very much easy for you. Even if you don't know DP, this very high level DP, only just the basic DP of like Fibonacci only, then also you will be able to think what this transition is saying. So I recommend you to first learn the concept of 2D prefix sum, then move further in this video. So let's see how we will be apply the concept of 2D prefix sum in this question. So here, as you can see, we are given that the hi and wi are of the range 1000 only, and we can also see that the hsws and hbwp are also of the range 1000. So what we can do is, we can actually make a grid of size 1000 cross, let's say 1000 plus 3. You can take any number 1000 plus something, let's say 1000 plus 3. We can make a grid of size 1000 plus 3 cross 1000 plus 3. This is the grid of size 1000 cross 3 plus 1000 cross 3. There are so many more rows and more columns, and so on. So what we will do is, suppose let's understand this test case. So here it is given us 5 rectangles and 5 number of queries. Here in this I won't consider every query, because here you can see it is of the form 100 cross 100. So it is won't possible for me to actually draw 100 cross 100 grid here. So for the sake of easiness, I will tell you and how to process the rectangles in the query. What I mean to say is, I will not process all the queries here. So first we can see that there is a rectangle of size 1 cross 1. So what I will do is, I will say, okay, let's first mark as this is 0, 1, 2, 3, 4, 5, so until 1000 plus 3. This is also 0, 1, 2, 3, 4, 5, so until 1000 plus 3. So what I will do is, first I will mark. Here it is given 1 cross 1. So I will say, okay, 1 cross 1, I will write it here 1. Then it is given me 2 cross 3. 2 cross 2 actually. Let's say it is not 2 cross 2. Okay, I change this. I say, let's say it is 2 cross 3. Supposedly I say it is 2 cross 3. So I will go to 2. It actually, this section, you can see, this section actually represents height. And this section, the above section which you can see, this actually represents my width. Okay, so let's say I move to 2, height is 2 and width is 3. So I will put here, what value I will put here? I will put here as it is. I actually, in this block I am putting the area. If height is 1, width is 1, area is 1. If height is 2 and width is 3, then the area would have been 6. Suppose now it is given 3 cross 3. In 3 cross 3 I will put 9. Here I will put 9. Now let's say instead of 4 cross 4, it is again given me 2 cross 3. It means there are two rectangle of height 2 and width 3. So here I have also already placed 6, so I will add 6 again. Let me clear out some space. I will add 6 again. So it will become 6 plus 6. In this way, I will fill the whole grid Okay, now after doing all the, after traversing all the rectangles, I will easily be able to fill all the grid, whole of the grid. Okay, now as I filled the whole grid, now let's first understand what does grid actually means and what does grid actually represents. Suppose I have been given a rectangle. We are actually done with the rectangle section. We are actually now dealing with the queries section. Now we will actually deal with the queries section. But we know that the queries are of the form ABCD, where AB also represents a rectangle and CD also represents a rectangle. So I will also deep dive some more sections of rectangle. So what I'm trying actually to say is, let's first understand with what this grid says. This is the height cross width grid, and every block of the grid represents the area. We don't have to fill the whole area. Other sections are filled with 0 only. We have to fill only those rectangles which are mentioned in the question. So let's say in the query we are given AB and CD. Let me remove out some section for clarity. Let's say I remove this section only. Okay, so let's say the query which is given to me is actually 4 cross 4 is actually 4 cross 4. Let's say it will be 1 cross 2. Let's say it could be 1 cross 2 and 4 cross 5. Let's say it would be 1 2 4 5. 1 2 4 5. What does it means? We have to tell all the rectangles whose height, which will enclose the rectangles of size 1 cross 2 and which are enclosed within the rectangles of size 4 cross 5. Okay, so what I can say is this is the height, this is the width, this is the height, this is the width, or I can say this is the height 1, width 1, height 2, width 2. Don't you think from the query I can say that the rectangle which I am trying to find must have a height between height 1 and height 2? Don't you think? Why I am saying it between? So that it will not touch the boundary. So what I can say is the rectangle which I'm trying, actually I want to find the number of rectangles which will satisfy this query, and all the rectangles which will satisfy this query must satisfy that the height of that rectangle should be between h1, that is 1, and 4. If it is either greater than less than 1 or it is greater than 4, or I can say if it is less than equal to 1 or it is greater than equal to 4, then that rectangle will neither be able to enclose 1 cross 2 and will not be enclosed by 4 cross 5. So what do you think? Can we say that the rectangle which we are trying to find out must have a height greater than h1 and must have a height less than h2? So let's say I mark 1 here, this one, and let's say I mark 4 here, that I want the rectangle which are having a height greater than 1 and less than 4. Now, don't you think same apply for width also? We have to find all the rectangles which are having, out of those rectangles which we have find out, don't you think we have to find all the rectangles which are having width greater than 2 and less than 5? Okay, so I will mark here 2 and let's say I mark here 5. So I can mark the boundary as like this. This is my boundary and this is my boundary. So what does this boundary represent? It is allowed for me to have a rectangle of size 2. This is you can see this is 2, this is 3. It is allowed for me to have a rectangle of size 2 cross 3. It is allowed for me to have a rectangle of size 3 cross 3. It is allowed for me to anything, but it is also allowed for me to have a rectangle of size 3 cross 4. You can see here it is 3, here it is 4. But it is not allowed for me to have a rectangle of size 4 cross 4 or 4 cross 3 or 4 cross 5 or even 1 cross 2 and 1 cross 3 and 1 cross 4 and 1 cross 5. If you think I am speaking fast, the coordinates I have set to you, like 4 cross 3, 4 cross 4, 4 cross 5, 1 cross 2, 1 cross 3, 1 cross 4. You stop this video and think why these coordinates will not be our answer. As I have just said earlier, the height must be between h1 and h2 and must be between w1 and w2. Actually in this question we don't have to tell. Wait for a second. Actually, okay. In this question, we actually don't have to tell the number of actually rectangles that fits the query. We actually have to tell the sum. Oh, okay. The method suits for both. We are actually okay. We are actually now we will tell the sum only. The path is same only. We are going in the right direction. So what we will do is we can see that the any coordinate that is 3 cross 4 can be our answer, because 3 cross 4 must will include 1 cross 2, and 3 cross this 1 cross 2 this query, and 3 cross 4 is enclosed within 4 cross 5, but the answer can't be 4 cross 3, the answer can't be 4 cross 4, the answer can't be 4 cross 5. Okay, so what we can see is, okay, it means I can say is the part which I am now going to shade, this section, the section which I am actually shading right now. Let me shade it darkly. After that I will remove this shade. Don't you think the area which this shade contains is our answer? Why? Because here this shaded area contains the block having value zeros and some values greater than 0. It contains the blocks having value 0. Why? Because those rectangles are not present in the question. And it contains the blocks which are having value greater than 0. Why? Because those blocks are filled with the rectangle which are given in the question. So, and if the blocks which are filled with value greater than 0 represents the blocks which are given in the question, it means, don't you think the area of this shaded region would be our answer in this query? Actually, we have in the question we have to tell the number of rectangles which satisfy the query. If suppose k1 number of rectangles satisfy the k2 number of queries, so we have to find the sum of all the areas in that. We have to find the sum of all those areas, that is those k1 rectangles satisfy those k2 queries. So as many as times the k1 rectangle satisfy those k2 queries, we have to find the sum of all the rectangles and return the area. What I actually mean to say is, let's say this rectangle, suppose a rectangle is there, satisfy some query. So we will add the area of the rectangle to our answer. Suppose that same rectangle satisfy another query, so we will again add the area of the rectangle to the answer. Okay, so focus and think it again. Don't you think this shaded area, if you know 2D prefixing, you will be able to think that this shaded area will actually contains the area of all the rectangles. This shaded area contains the area of all the rectangles which satisfy this query. This is the important line. This shaded, again I am repeating, this shaded area contains the area of all the rectangles which actually satisfy this query. So for every query, we will find the area of this shaded section. We will traverse every query and we will find the area of this shaded section and find the sum of all the areas of the shaded section, and this would be our answer. So as you know that we are only traversing query, and this area of the shaded section can be found in order of 1 only. Using the concept of 2D prefixing, which I am going to tell you in right now after this. So the time complexity will be order of q, which is order of 10⁵, which is very less as compared to the previous one. So now I will tell you how to apply the concept of prefix sum here. Actually 2D prefix sum. Those who know the concept of 2D prefix sum will easily be able to figure out that with the concept of 2D prefix sum, we will be able to get this area, and for every query we will find this area and add up to the answer and report the answer. So, but those who don't know what is the 2D prefix sum, I will brief in just 1 minute. In 1 minute. So let's say a grid is given to us, and the grid is filled with some numbers. Let's say 1, 2, 5, 8, 7, 6, 9, 12, 13, 14, 0, 8, -1, -6, -7, 3, 2, 8. Let's so on and so on. Suppose in the question I have the question asks me to find the area of this section, or I can say the question asks me to find the sum of all the elements in the red range I have marked. You will say I will traverse the whole section and find the answer. Okay. Now it will say me to find the area of this the sum of all the elements of this section. So you will say I will again traverse and find the sum. If you are asked this to do 10,000 times, so you will easily be able to understand that I can't traverse the whole sections again and again and find out the sum. So what we can do is we will apply the concept of 2D prefix sum here. In these types of cases, we will apply the concept of 2D prefix sum. So let's suppose I have the sum of, let me change the color. Let's say I have the sum of this section. Let's say I have the sum of this section. The section I have marked with black. This section. And let's say I have the section of, now I am marking with light green. Now let's say I have the sum of this section. The light green section also. So I have actually the values of two sections, this black section, this light green, this black section, this light green section. Now let's say I mark the third section with blue. Now let's say I have the value to this blue section also. This blue section also, I have the value to this blue section also. And now let's say I have to find the value of this red section. I have to find the value of this red section. It is a prerequisite that you must draw all these things in the copy and try to understand what I am trying to say. And let's say I have also the area of, now I am marking it with actually dark red, this section. I have also the area of this section. So don't you think the area of red section, the area of red section which we want to find is actually the area of black section plus the area of light green section plus the area of light blue section minus the area of dark red section. Don't you think this should be our answer? This must be. Don't you think this must be, the area of this red section must be equal to the sum of these three sections, subtract this section, is the area of this red section. If you easily be able to figure out what I have drawn in this, that the red is equal to the black plus green plus blue minus dark red, then you will be easily be able to come up with the DP section. What I am actually written above, that the DP of ij is actually DP of ij. See here, ij plus this, okay, this plus this, we have subtracted this and we have added this. So there are 3 additions and 1 subtraction. You can see there are 3 additions and there is 1 subtraction. So this is actually the concept of prefix sum. You have to go in detail of it to understand what we had applied here. I again briefing it out. For every query, we will find the area of this section and we will add the answer. We will add the area of this to the answer and at the end we will report the answer. Why we are considering this? We know that every query, you will be able to see these blue lines which I have drawn. You are very much sure that these blue lines actually represents our query. These blue lines actually represent a query. The height is of the range this, the width is of the range this. These blue lines are actually representing our query only. And in the query, we found the sum of these values, that is the sum of rectangles, and we have to report this only. Now let's move to the code section. So I have actually find out vk of AB is equal to A into B. What I've told you, make a rectangle of size 1003, or I can say 1005 cross 1005. Then do vk of AB is equal to A into B. Then apply the concept of 2D prefix sum. After applying the concept of 2D prefix sum, you can traverse each query. Here you can see I've traversed each query, and I have do C minus minus D minus minus. When you will write code, you will be able to understand why I have done C minus minus D minus minus. Then I have easily be able to figure out what is the answer. Actually, we have to tell for each query. For each query, we have to tell how many rectangles. For actually each query, we have to tell the sum of all the rectangles which are enclosed to. For each query, we have to tell. So at the end, I have print out the answer then. So this is actually order of one operation only. So we have completed the whole code in order of Q only. If you like this video, do share and subscribe. Thank you.